Robots are improving efficiency in modern warehouses. Today's guest is Akash Gupta from GreyOrange Robotics, a company that designs and manufactures robotics systems for distribution and fulfillment centers. These robots are incredible. They pick items, they move shelves around, and they coordinate with each other. In this episode, Akash and I discussed the software and hardware challenges of making a coordinated system of robots. The audio quality for this episode is not perfect, and we're sorry for that. We recorded it last year before we had all of our audio processes worked out, and we've been considering whether to post it or not. We think the material is interesting enough that our listeners will like it in any case. If you're a fan of Software Engineering Daily, we really want to know how to improve. Please take 5 minutes to fill out our listener survey if you have not already. There's a link to the survey in our newsletter and on our website, and we really want to know what you want to hear more of, what you want to hear less of, what you think. We just want to know about feedback. So please fill out that survey and get back to us. After a quick word from our sponsor, we will get to this episode, Robots in the Warehouse, with Akash Gupta of GreyOrange. There are hundreds of tools for looking at user data. Google Analytics, Optimizely, Mixpanel, Customer.io, all of these tools can be useful for figuring out how users are engaging with a product. Unfortunately, many of these tools require you to write domain-specific code in order to gather the data and set up your integrations. What if I told you that there is a product for writing code only once, a single API, a tool for unifying your data and performing analytics on any platform from Marketo to MailChimp? Segment is that product. Segment simplifies your analytics so that you can collect customer data with one API and send it to any of hundreds of tools for analytics, marketing, and data warehousing. With Segment, a developer can satisfy all the stakeholders at once, from the data-driven account manager to the app-happy marketer to the data scientist who needs a data warehouse with a clean schema. Thanks to Segment, your CEO will fall in love with your newly efficient integrations with tools like Zendesk, Intercom, and AppNexus. I'm falling in love with Segment just talking about it. Thanks to Segment for sponsoring Software Engineering Daily. If you are listening to Software Engineering Daily and you have not tried Segment, give it a shot at segment.com and tweet at Segment to let them know you heard about the product on Software Engineering Daily. We wouldn't be doing this show without the sponsors, so thanks again to Segment for sponsoring this show. Now let's get on with this episode. Akash Gupta is the co-founder and CTO of GreyOrange Robotics, an industrial robotics and automation company based in Gurugram, India. Akash, welcome to Software Engineering Daily.
Thank you, Jeff.
GreyOrange Robotics focuses on automating warehouses and distribution centers. Tell me about the two products that you have built for warehouses.
Right. So we have two products majorly called sortation systems and Butler systems. So sortation system was something which we came up earlier, so we start with that. So sortation system basically sorts shipments. So once the different e-commerce companies, pick and pack the items and, they turn into a shipment. Then they put these, them into a conveyor-based systems, which has different kind of, I would say, deflection arms or a deflection base where they get sorted. So let's say once you have, packed the shipments, you want to sort them into either different courier vendors or different regions and things like that. So sortation system basically allow you to distribute them quickly into different regions and then ship them very quickly. So yeah, that's what sortation system does. We do around 6,000 shipment sortation in an hour. So yeah, that's it. I think we are coming up with one more new sortation system called cross-belt sortation, which will have the capability of doing around 12,000 to 18,000 shipment sorts per hour.
Sure. So, and let's start by talking about the Butler actually. So, what is the Butler? That's the other system that you mentioned.
Right. Now, Butler is basically a group of, I would say, intelligent autonomous ground vehicles, basically who can collaboratively do different stuff in warehouse. So the concept of Butler system is basically kind of goods to man principle. So normally, what happens in warehouse is that as soon as you place orders, right, it goes to the warehouse, and then people start going towards the inside the warehouse to pick those items and get back for packing, right? So now what Butler system does is it basically completely reverses the whole phenomena of a person going to the inventory inside the warehouse and picking the items that have been ordered. What Butler system basically does is that it whenever the order hits the warehouse management system, it makes sure that the butler comes with the MSU or the rack that contains the items to a point which we called as pick put station. So instead of person traveling and doing all that, he the person stands still while the items keep on coming to him which he needs to pick. So basically it reverses the whole phenomena of you know goods to people to goods, to goods to people. So yeah, that's in nutshell what the Butler system does. And
Right. And so to put a cap on that, so you have these butlers, these little square robots that move
right,
around on the ground, and they'll pick up shelves, entire shelves of items, and then they'll
yeah,
bring these entire shelves of items to the picker, and then the picker just selects items off of those shelves and puts them in boxes. Is that correct?
right. That's right. During picking, we have a lot of other indications as well, like pointers, and there's a graphical screen as well to help him identify which are the items that you need to pick from the rack that has arrived in front of him.
Hmm. So tell me about the different hardware components of the Butler system, because there's not just Butler, there's also some other pieces of
Uh,
hardware
right.
that interact with this platform.
That's right. So if we look at different components of Butler system, we are talking about butlers, then we are talking about auto docking and charging units as well. So because we want to make system very independent of human beings, the robots go and charge themselves on auto docking stations. So again, auto docker and charging station is one another component. Another component is basically the pick put stations. Pick put stations is basically, I would say, the stations at which the butler brings the rack and where people do the inventory picking and transaction of inventories. So another thing that normally is emergency system, which basically ensures the operators or the warehouse manager to stop the system at any point of time. So yeah, these
Hmm.
are the different elements of butler system.
So tell me more about the Butler warehouse control system. It seems to be there's like this central system of control that dispatches actions to the butlers. Is that correct?
That's right. So normally, what happens is that although the whole thing is still very distributed, the whole architecture is still very distributed, but there is definitely a central system that makes sure that the distribution of different tasks is done in a certain way. So basically, see, one thing we need to understand in Butler system is that. When a butler comes with a rack to a station, he's not the butler control system is making trying to make sure that the person picks multiple items from that rack rather than one single item, because else there's a lot of optimization that needs to be done, because else bringing one item one rack for one item is not very efficient. So
Hmm.
Butler's control system basically optimizes and merges the orders together and make sure that the number of racks required to fulfill orders is very less or very minimum. Again,
Yeah.
this goes back to putting strategy as well, right? So what you try and do is that items that are being ordered very frequently, you try and put them in same racks or similar racks, and items which are being ordered together. So let's say if iPhone and a iPhone cover is being ordered together. So Butler control system makes sure that while putting, they are put together in the same rack. So whenever that rack comes for picking, a person can pick both the items. So Butler control system basically optimizes different algorithms, as well as once it has identified that which rack needs to go to which pick station, it assigns that task to a butler to kind of get that rack to the pick station. Another
Mm.
sense of optimization that happens again is that's again very core part of the butler system is things like path planning, path reservation, and we again use optimized form of A-star algorithm to kind of find the right path for the butlers. Also, we need to understand that when you say that, okay, butler go from point A to point B, right? You cannot reserve the complete path, because then there'll be a lot of traffic jams. So you do dynamic reservations of path while a butler moves from point A to point B. So yeah, that's another very core part of the whole butler control system.
Interesting. So now that we've talked about the butlers, and we'll talk a little bit more about them going forward, but let's talk about the other robotics platform, the sorter.
Mhm.
So as you mentioned, the sorter is kind of this conveyor belt system that moves things into it sorts things into different categories.
Yeah,
And so is that accurate?
yeah, that's right. Yeah, that's right.
Okay. So in computer science, sorting is a common problem, and there's a large class of related sorting algorithms. Is sorting in the real world similar to sorting a set of data on a computer?
Uh, it's similar, but I would not say very likely. There are different ways of doing it in a physical thing. One thing that we need to understand is that we are talking about physical packets. So you don't have a that good a control that have on your sorting strings, or data that you sort on your computers. So I would
Hmm.
say it's not it's a slightly different from that. Uh,
Okay.
Also, here what you need to understand is that the 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 where which category which packets need to go in is being given by the customer. So let's say there are 10 categories. The customer clearly mentions that. So I'll explain a little more about sortation system to explain this. So sortation system basically contains multiple parts. One of the most important part of it is scanning system. So scanning system scans the barcodes over the shipments that are being put on the system, and then there is a control system for sortation system as well, which basically figures out that which category does this barcode belongs to, and then that is sorted into that category. The tough part of the sortation system is that you need to do a very I would say critical FIFO management. So if you really screw a little bit on FIFO, then all the packets will go in a wrong categories, right? So we follow a very strict FIFO structure while doing sorting in the sortation system.
Mm. So do the sorter and the butler work together?
Yes, so after the shipments are picked on the Butler system, they are packed and then put over the sortation systems for final bagging and dispatch. So yeah, there is in fact we have done it in quite a number of warehouses where there's then the complete chain from picking to packing to sortation is done by sortation and Butler system.
Hmm. And so all of your products, the sorter and the butler, they work together on a common platform.
Mhm.
I'd like to know more about this platform. Like, what are the common software features across your products?
So I think what we have done now is one very important part of Butler system and sortation system is what we called as interface or integration layer. Integration layer or interface layer is something that enables Butler system and sortation system to connect to different warehouse management systems. So when you go into any warehouse and install one of these products, you need to connect to their warehouse management system. So we have exposed a common layer for Butler system and sortation system, and as well we're planning to coming up with few more products in the same layer, so that we can interact very, I would say, easily to standard warehouse management systems as well as other customer warehouse management systems. So that's one thing that we have a standard layer for integrating all our hardwares for to any of the warehouse management systems like Manhattan or Red Perry,
Hmm.
and the ones which are custom developed. We have a very standard API. So we made integration a lot easier than what normally systems have, right? And
So you're talking about the API between
right,
your system and the external system, right?
exactly.
So I'm curious about the API between your different robots. Like, what is the API between the sorter and the butler?
Okay. So normally, what happens is that firstly, sortation system and butler system. Butlers do not interact with sortation system. The butler control system basically interacts with the software sorter control system. So things like that. Okay, these packets have been picked and they're gonna be expected on sorters, and things like that are basically communicated between butler control systems and the sortation control system. So there is, I would say, it's not a very chatty system. Whenever a set of items are picked and packed, that information is basically passed to the sortation system to ensure that it is sorting things in the right
Hmm.
category.
Okay, interesting. So it seems like these two robotics platforms they're operating kind of serially, so they don't really need to have much
Yes.
back and forth between them.
Yes, a lot of back and forth is definitely required when the Butler control system is interacting with butlers, because that's a very, I would say, tedious communication, and pretty much every few milliseconds there is a communication between butlers and the Butler control system, which is over Wi-Fi.
Yeah, let's talk more about that. So, from a software standpoint, how do you coordinate the actions of numerous robots?
Right. So I think, as I discussed earlier, there is something called a reservation system. So there is there's a part of control system which knows where each of the butler is, as well as when butlers are moving, when they move from one grid point to other grid point, they send this information back to the control system that I've moved. Now my current position is this grid point. So let's say a butler gets a command from moving from point A to point B, right? What happens is that the control system calculates a right path to kind of go from point A to point B, and then what it does is, as it starts moving, it starts reserving the next three grid points that it will be in some time, right? And so
Mhm.
if at the same time the other butler tries to reserve a path, right, then it will not be able to reserve, making sure that there are no collisions, right? So if you talk about this, every butler on the ground has a process over the server as well. So basically, once a butler gets a command to move from point A to point B, it tries and places a request to the reservation system that I want to reserve the next three grid points that I need to move to, and the reservation system manages and makes sure that there is never two. It doesn't give reservation to two different butlers at the same time.
Wow. So how do you uh like how do you synchronize this? Like, how do you ensure that there is no edge case where you can end up with some collision or have, because I imagine there's, potential scenario where like there's latency or there's a, I don't know, temporary network partition, all the things that can happen with cap theorem.
Right,
um
right, right.
how do you handle those?
Yeah, I know what you're talking about. So yeah, so basically, what happens is that what you really do is that you always first reserve and then only ask any butler to move. So making sure that once you are 100% sure that you have reserved the next three grids, and then only give that I would say permission for butler to move, right? And also, I think one thing that really helps in doing that is what we're using to do the complete system is we're using a language called Erlang. It's a
Yeah.
yeah yeah it's a functional language that we are building the complete system on, right? So what we are, and we are using Riak as the database, making sure that at least the database latencies are very less. But in terms of I would say these calls are sync calls, so we make sure that anything is definitely reserved before you give any permission to butler to move. Also, this happens really real time, I must say. So you can't really see that okay, a butler is waiting for the reservation, but in the back end it's always a sync call, making sure that only once when the reservation is done, we you give permission for butlers to move.
Interesting. Can you talk more about your Erlang message? I imagine it's a message passing system between your butlers and the central control system. I mean, how did you decide to use Erlang, and what kinds of things have you built with it?
Okay, so the decision of using Erlang basically came from the point that we so a warehouse can have as large as 500 to 1,000 robots working together. So we really wanted a system that can really scale, and Erlang at its very core is something that can definitely help you scale, right? And one other thing that while we were evaluating Erlang, we figured out is that you can handle multiple processes in a very, I would say, different way than you handle in C++ or any of those kind of things. You can go to a very one thing that you want in these kind of softwares is that things need to be very real time, because you are doing a lot of real-time communication and processing and things like that. So another option was C++, but then getting a very good Erlang is basically a very good compiler over C++, which helps you to really handle processes in a very different way and in a very organized way. Also, one thing which is great about Erlang and which we use a lot in our server software is that it crashing of a process is inherently built into it. So you can very well do saving the context of a process and then let it crash and then spawn a new process to kind of continue with it. That is something which is I would say really good in built in Erlang to kind of which is very suitable for systems like us.
So when a butler crashes, do the other butlers continue operating?
Yes, absolutely. So let's say if due to some reason the process for a butler on the ground, so butler doesn't crashes, it's the process of that butler. Due
Right.
to some random reason it crashes, it makes sure that it saves the context for that butler. In that case, even let's say if a butler is performing some task, and if let's say it's saying that okay, go to rack A and then pick it up and go to point B. Let's say if the process for that butler crashes, the context of the whole process gets saved, and then I would say the task management system ensures that it distribute that task in other butlers rather than that task getting stuck. So that pretty much happens very nicely in Erlang.
So you also mentioned that you use Riak as the database. What are the advantages of Riak?
So I would say when you start using Erlang as a system, there are a couple of databases that really I would say work with Erlang. Amnesia is one of them, and React is another. So I think you can use Amnesia and React both at some point of time, but let's say if you want it to be highly scalable, so we'll see React is something that works really well when you have, let's say, 4 or 5 different nodes, and still you want a distributed database. So again, one very important thing that's about React is that you can very have easily have distributed nodes of the database that can work together. And for us, where database goes to a decently high size, and even number of IOs happening on a database is really high, you would really want a database that can work very well when you separate it into different nodes, and still do there's a central system that is trying to use that database.
What's the consistency model of React?
I think what happens is that it makes sure that it locks whenever there are different nodes. It makes sure that it locks when locks for a certain IO, and then unlocks when this is done. So I think that's how the consistency is. I would say maintained in React.
Okay, interesting. I mean, what are the typical things? What, like, did you try out other databases before using React, and you had problems like I don't know, some conflict resolution problems, or
So we were initially on Amnesia, which is normally that is used with, I would say, Erlang. The
uh-huh.
only problem there was that we couldn't go a lot distributed in Erlang, so that's in Amnesia. So that's been one reason I would say we shift to React.
Interesting.
Your company has important projects that need to get done. The iOS app needs to be rewritten for Android. The database needs to be migrated. Your continuous deployment system needs to be built. The website needs a complete redesign, but you don't have enough software engineers and designers to get all this work done. TopTal is here to save you. TopTal gives you exclusive access to the top 3% of freelance talent. Software engineers and designers, from Python to PHP. TopTal has the freelance talent you need to get your projects finished on time with top quality. In the past, we had to worry about flaky freelancers with poor communication skills, unreliable internet connections, subpar technical skills, and so on. TopTal screens for these kinds of things and only works with seasoned professionals with tremendous problem-solving skills, personality, and drive. Here's how it works. TopTal's internal team of senior engineers will work with you to understand your project scope and your talent needs, and they will custom match you with just a few hand-picked candidates. This means that whenever you need to add top-shelf talent for a critical project, you can be connected with pre-screened engineers who are hand-picked for your needs. And the results are impressive. TopTal clients conduct just 1.7 interviews for every hire that they make. All you need is to come ready with some decent technical specifications of your project, and TopTal's team of engineers will take care of you from there. If you are looking to add critical talent fast and you need a source you can trust, go to toptal.com/sedaily. You can also send me an email directly at softwareengineeringdaily@gmail.com, and I will personally introduce you to the team at TopTal so that you can learn more. We live in unique times. The nature of work is changing, and more industry-leading companies from Airbnb to JP Morgan are realizing the benefits of scaling quickly and staying flexible by working with elite freelancers. So if you're short on resources for your projects, check out toptal.com/sedaily. Thanks to TopTal for sponsoring the show.
How often do you update the software on the machines that are running? Like, do you push out updates to butlers that are running?
Definitely. So all the butlers can be updated while they're running. So not while they're moving, but while they're running. So you can as soon as So the Butler firmware inside Butler have something like where you can send in the, I would say, firmware update packet, and they will stop, and then they'll receive the firmware over Wi-Fi and then burn the firmware. So inside the Butler, basically there are a couple of microcontrollers that do the navigation system as well as communication from the server. So majorly we are using I would say Cortex A8s inside the Butler system to kind of do different parts. So these Cortex 8 controllers are basically connected over Wi-Fi, and they can receive I would say firmware update packets and then burn the firmware safely in them, and then again start running. So we definitely keep on pushing, I would say, monthly updates on Butlers as well from the Butler server.
Have you had to do much in the way of machine learning?
So okay, we have just started doing like that. I'll give you an example. Right now, we are concentrating on, I would say, using some kind of, I would say, some methods of machine learning for making sure that whenever hardware gets degraded, you can you can, I would say, still maintain the performance of the bot. So I'll give you an example, to explain this. Right. So let's say butlers are moving on the grid points, and after some time, let's say 8 months or 10 months down the line, the one of the butlers motors, let's say right motors, the efficiency of the right motor has gone down. Right. So what happens is the butler starts moving, I would say, slightly off the grid. In and while we very well know that okay, when the Butler started moving off the grid, what we start doing is we start figuring out what was the historical data of that Butler, and when did it start moving off the grid, and what was the pattern of it moving off the grid. And once we figured that out, we start the Butler system itself starts tuning the, I would say, the different PID parameters of the motor to make sure that it again starts, it overcomes for its efficiency and starts again moving, exactly on the grid. So these kind of systems are being, I think, are being, placed, and we are doing these kind of things for different other aspects of Butler systems as well. Another one good example of it is, so let's say Butler is working in a warehouse where each order contains, let's say, two items. So there are two order lines for each order, and then suddenly, let's say, what happens is that number of order lines per order starts increasing, right? So slowly, the Butler system starts analyzing that, and then starts sending lesser Butler on each pick station, which has more number of order lines per order, because the person is going to take more time to pick more order lines. So these kind of, I would say, optimizations has been we have started doing through AI and machine learning.
So I guess you didn't have to do that early on because your problem is fairly well formed. I mean, I guess that's one of the advantages of working in a warehouse is you really get to control your circumstances, and it's a very well formed problem.
So a lot of times it's that's not completely true, because the input that you are getting is very variable. So at some point of time you might get I would say 100 orders in an hour, and at some point of time you can get 2,000 in an hour. So still you would have to understand what is the order behavior pattern, and then tweak your so this is always obviously done automatically in the Butler server. Understanding the order behavioral pattern, and then tweaking few variables inside the Butler system to make sure that it can work with its full efficiency in that kind of order pattern. So that's I would say something that is done according to the Butler server basically understands the pattern of the order flowing in, and then automatically tweaks a few variables to make sure that the efficiency of the system is still maintained.
So could you delve into that a little more? Like, what happens if the if the warehouse gets slammed with a bunch of orders all of a sudden, and how do the robots adjust?
Yeah, so basically what happens is that there is a fair distribution of robots between pick station, put station, and charging, right? So depending upon how the load is, so let's say if there is a too much, there are too many orders that are slammed into the system, then the charging of butlers gets stops, and every all the butlers start working only for pick. We starts giving lesser priority to the put stations, and we start directing more butlers to the pick station, and so things like that starts happening. Basically, then you increase the priority of the pick in the complete system to a higher value, so more butlers are then start concentrating towards helping in picking of the items rather than putting or charging or any other tasks.
Interesting. So I'm curious about the management perspective of this company. Like, how do you there's so many different things you need to do in a robotics company. You've got hardware issues, software issues,
Right.
customer issues. How do you manage your engineering teams?
Right. So just to kind of get the context here, we have right now, I would say, five engineering teams. So starting with mechanical engineering, then electronics and electrical, then we have firmware, then of course we have server and UI UX. So these are the five engineering teams that we house. I think how we have been able to manage this whole startup is that. You need very strong, I would say, technical architects at the top of each engineering team, so which can help in making sure that that part of the engineering is really strong. And then with these strong technical architects for their particular I would say department or particular engineering, you need one more person with them who are very, I would say, cross-functional in nature. So our major teams are led by two people, which are one person who is very, I would say, strong in their own field, and then there's a person who has a very good understanding of cross-functional nature of product development. So these two people are basically these are the two people which try and lead the team, and all the four or five cross-functional people, they try and work with I would say experts in different engineering field to make sure that the product layer is very stable and I would say competent. So that's one way of doing it. And again, there is another team of product management and program management which help in executing different tasks. So that's how the organization is basically structured.
So these cross functional people, like this management structure is really interesting, where you have somebody at the top of each part of the engineering organization, and then you also have like a cross functional person. Does the cross functional person just spend a lot of time in meetings that are in the adjacent engineering organizations?
Right. So cross-functional person is definitely required to attend meetings, and rather than he definitely attend meetings, but he also makes sure that there is no communication gap between different, I would say, engineering teams. So there's no communication gap between embedded team and the server team. Responsibility of team members in the let's say server team and embedded team. So they make sure that there's no break in consistency of, I would say, product definition while you move from mechanical to UI UX, right? It's a while you have five large teams working together on a single product, the biggest challenge is that there's no, I would say, consistency break during product definition. So
Can you give an example of when that's happened, when you've
yeah,
had a
so
consistency break?
I'll give you a classic example of that. So let's say you are building obstacle detection system for the robots, right? So to build that, you need your mechanical team to identify where is the right place of where is the right location you would put your obstacle detection system. Your electronics need to understand, okay, that these are the circuitries or these are the PCBs and these are the sensors that are required to do that. Now your firmware team needs to program them and understand them, that how does they respond to different obstacles that come in, and the server team needs to handle that once the detection system says that there's an obstacle, they need to inform to the server, do the reservation and things like that. And on the other hand, UI UX people needs to show that in on the map of the Butler server that okay, this robot has found obstacle. So it at any point of time, let's say if a electronics guy or a firmware guy, there is a lack of information and communication there that where the obstacle detection system is getting placed, he might write a completely different algorithm and code and things like that, and
Mm.
realize at the very end when the prototype comes to him that the last 3 weeks of the work is completely scrapped, right? So things like that, do happen sometimes, but to fight things like that, that the structure that we have formed is something to kind of mitigate these problems.
Do you have any interesting software testing strategies in order to align these different teams together?
Right. So what we do is that we have a lot of emulators. I would say emulators
Mm.
are like simulators plus hardware. So emulators. So pretty much everything that goes on to the real systems is very very, I would say, rigorously emulated over things. So you build an emulator where even the firmware codes are running on the microcontrollers itself, and the server is running. The live code, and then you have another set of microcontrollers that try and I would say emulate order or things like that. So yeah, so you we have a very very, I would say, in fact there is a separate team that only works on creating emulation tools for different teams so that we can test things well before putting things on ground.
Okay. Your vision for Gray Orange is a global company. How does starting your company in India change this trajectory or affect this trajectory?
Yeah, so I'll be frank on this. So normally, hardware products from India are not that common. So that definitely kind of gives a little, I would say, pushback when you go and say that you have a hardware product which was built out of India. So I think that's definitely a tough challenge. But I guess as we grow and we now in fact our team now have a lot of other people from Singapore and Hong Kong and Japan and things like that. So I think we're trying to make a much more I would say international team, so that we get, I would say, the best of different geographies in terms of technology, understanding of a platform and things like that. So yeah, it's a little tough to kind of you know you know directly sell your products outside India. But I think we have started doing well now, while we have a couple of Butler installations in Hong Kong as well as sortation installations in different parts of Southeast Asia. We are doing a
Mm.
Butler system in Japan as well. So I would say initially it's definitely tough, but I would say we need to build a good brand to kind of make sure that we mitigate with that problem.
What do you think is unique about the engineering culture in India?
Right. So I think one thing that is really required when you are doing a product like this is you need to be really really iterative, instead of thinking that you're gonna have a waterfall model and just think about something and land up after 10 months with the product. So I think product developments like one we are having need to be very very iterative, and I think that is something which is good in, I would say, Indian engineers. They are ready to, I would say, accept mistakes at some point of time and say, okay, these are the problems. Let's just try and do it again in a different way. So I think that these they are not, I would say, very very fixed on something that that this is the only way of doing it, and or I'll only do it in this way. So iterativeness is something which is which we are very comfortable with as far as Indian engineers are concerned. So that pretty much matches up with the whole hardware development philosophy with iteration in this product development.
Do engineers in India see engineering as more of an art or more as a science?
I think we would see it more as a science, not as art.
Hmm. What about you personally?
Personally, I think I would still feel it's more of a science than art. In fact, if I slightly go into a detail, there are different levels of engineering. So I think when you get a product concept, I think getting to the point where you have a high level design doc is high level technical design doc or technical requirement doc. I would say that's more of a art. And then once you have a high level design doc or something like a technical requirement doc, then I think it's more kind of a science. So from a concept to a high level technical design doc, I would say it's more of a art. And then once you have a very clear specification documentation for your I would say product, then it's more of a science. So that's at least my view on it.
Yeah, I think that's a very very balanced way of looking at it. So I'm curious about the customer onboarding process. Like
Mhm,
when a customer decides to go with GreyOrange and have these robotic systems put in their warehouse,
mhm.
I mean, how do they get started? Do they need a totally empty warehouse and you guys suit it out, or how does the onboarding
So,
process
so
work?
yeah, we have been doing both kind of projects right now. So greenfield and brownfield. Greenfields are the one which where you get brand new blank warehouse where you wanna build, and brownfields are the one where operations running, and then you're gonna take a certain part of the warehouse and then automate it
Yeah.
with the Butler systems. So I think we have a small team that firstly does I would say evaluation of the warehouse and places, and then comes up with a list of things that needs to be done. So then you get to a FNI team and get these things done. So while the whole warehouse, I would say, evaluation and preparation is happening on the background, the integration team starts working with the integration team of I would say of the customer to do API integrations and things like that.
How modular is the typical gray orange deployment? I mean, can you make accommodations for any types of warehouses that have some sort of edge case?
I didn't get it. Modular in terms of scalability or modular in terms of getting different components in. Can you explain me that?
So like depending on how the different where I mean I imagine not every warehouse customer is the same. I mean maybe they're more similar than I think, but are there any types of warehouses that where you can't your system is not modular enough?
Oh, okay. Yeah, I know what you're saying. So what we have done is, in fact, initially when we were doing, I'm sure we faced a lot of problem in the same front because different warehouses are different processes. So you need to map that process with your Butler system if you want the whole ecosystem of that warehouse to work well, right? So I think uh, learning from that, what we have done is that we have made a very nice tool for I would say process customization and process mapping in a warehouse, in which you can play around with different steps and processes and say that okay, if you're doing I would say quality check, then these are the different steps you can do in quality check, and you can choose any of these three steps.
And you did mention scalability. That's an interesting question. Like how big can these warehouses get?
Right.
How
So,
many
so, so again, a very, very, I would say, important feature and a really good feature for Butler system is that the you can really scale warehouse, and that's why it's been really popular as well. So let's say, for example, you have a 100,000 square feet warehouse, but you really want to only start with, let's say, 20,000 square feet. You
Mhm.
can only do gridding, and you can only run whole thing on I would say on this part of it. And let's say 3 months later you want to expand it, you can just extend the gridding and and throw a few more robots and still gonna run together. So you can keep on expanding till from 10,000 to 100,000 without really affecting any other parts of operation. So yeah, so it's absolutely scalable on the go kind of a thing.
Very cool. How is the tech industry in India evolving? Is it becoming more of a startup friendly environment?
I would say software industry, definitely hardware industry. I think in hardware industry, will still take some time to kind of catch up and get to that kind of ecosystem where you can do very quick hardware prototyping and things like that. So software industry, definitely we are right up to that point where there is a very good, I would say, startup ecosystem and culture. Hardware system, we are still catching up.
Well, Akash Gupta, thank you for coming out to Software Engineering Daily, and I look forward to seeing more great companies like GreyOrange emerge out of India. It's been a pleasure chatting with you about robotics and warehouse automation.